Alright, so can you see my screen?
Yes, sir.
Yes, sir.
Which one am I talking? Not this one. Not this one. Yeah, probably this is the problem I'm talking about with you, right? This is different format actually. A different format equation is same, but right now over here I try to explain in another language actually. Another language means the representation of this question is a little bit different. You can read that question from here actually. Yeah, is there any question? Someone?
Sir, I can't see the sheet,
You cannot
the
see it?
screen.
Screen? Why?
I don't know.
Did you join from the cell phone or from your desktop or laptop?
My cell phone.
Oh, do one thing, then try to join again.
Okay,
Exit,
sir.
exit the room and join again.
Okay, sir.
Yeah, probably in this question I changed a little bit. Probably I add one more question at the end. So what are that? I asked you to draw that curve, right?
Yes, sir.
So up to which I solved 2 or 3.
Sir, 3, sir. 2 and 3.
Till 3, sir.
Till 3, instantaneous velocity, right?
Yes, sir.
Yes, sir.
At t, did I plug in the time?
Yes, sir. T is equal to 3 seconds. We have used.
So that's mean we already discussed about this part actually. Calculate that instantaneous velocity at t equal to 3 second. And they ask over here in terms of magnitude and the direction. So you can find out because you know how to find out that magnitude and direction of a vector, right? So if you can find out that vector, probably I solve that one. This is the average velocity per, and this is actually your instantaneous velocity, which I write dr over dt v equal to dx over dt. It's a two-dimensional, so that's why I write in that form. And this is the function over here, and this is the function actually for x function, and I take the derivative of that function because it's a 2. If you take that derivative of constant function 2, so it should be 0, and this is going to be that 0.25 t square is going to be that 0.5 t, and this is the y function over here, and I take that derivative also that y function, then I got this one 1 plus 0.075 t square. Then we find out this, I just plug in into this equation. This is that general equation for instantaneous velocity. If you plug in into this equation, then I also plug in the time at t equal to 3 second. If I plug in the t equal to 3 second, I'll find out this equation, which is like the velocity in a vector. And then I also find out magnitude and the direction of that vector. This is the magnitude. You know how to find out the magnitude. And I also find out the angle, so which is minus 48.15 or 131.85 actually. Right, so this 135 from positive x-axis, and this one should be negative x-axis. I should write on that way. All right.
Yes, sir.
All right, now let's move to the forward direction. So they also find out that instantaneous acceleration, right? So instantaneous acceleration, so I will find out using that formula, which is actually a should be dv over dt, and dv over dt would be simply dr square over dt square. It's the second time derivative of the position function. Do you remember when I'm talking about, we find out that velocity actually dx over dt, sorry, not dx, I should write down the in a general format of position function, which is actually that r. I'm supposed to write it should be dr over dt. This is the velocity. So if you take that, acceleration is obviously going to be dv over dt. Now, so this v, if you plug in over here, so v actually dr over dt, 1 minute. So then you will find out this a is going to be simply d square r divided by dt square, which means the second time derivative of that position function. And since this position actually that 2D position, two-dimensional motion actually over here, so that's why it should be in term of this function actually dx square dt square I hat plus d square y divided by dt square z hat. And then I actually, if I take that second time derivative of that position function, I will find out these equations simply. You know how to find out that position function, right? I hope you can understand that how we take that position function. So this will be actually your position acceleration, actually not that position, I'm sorry, it should be basically that instantaneous acceleration as a function of time. Look at this, over here is the time over here, so that's why it should be simply that part. Then they also asked me find out that acceleration at t equal to 3 seconds. If you plug in that t equal to 3 seconds into this equation, I make it box over here, so it's with a 0.5 I hat plus 0.15 t. So t actually the 3 second. If you plug in the t equal to 3 second over here, it should be 0.45 j hat. So that should be actually the instantaneous acceleration. And you are supposed to find out that magnitude and the direction of this vector, which is that instantaneous acceleration at a time 3 seconds. All right. Now, can you tell me what are the other question over here? Can anyone tell me what is the other question over here? CR7.
Sir, the question was draw the cars Vx versus t and Vy versus t, Ax versus t, and Ay versus t graph.
That I think there is one more question actually after that.
So that was the previous one, sir. Is the car moving at a constant velocity or constant acceleration?
Exactly. So I'm looking for that one actually. So these are the two question extra over here. Look at this. This is the same problem actually. I solved this one actually at last year. No, 2 years ago, 23rd February, 2022. At that time, I discussed that problem actually into online. At that time, it was online semester probably. All right. So I add two more question into this question actually. One question actually is the car moving at a constant velocity or constant acceleration, right? Look at this, your velocity function is what? If you look at that velocity function, this is the velocity function, right? So which I'm supposed to write, it should be v was 0.5 t I hat plus 1.75 t square. 0.5 t, right? I hat plus 1 plus 0.075 t square into j hat. This is the total y component. This is actually x component because it is along to that I hat actually.
So it was minus 0.5.
Minus? Oh,
So
over here.
minus 0.5 t.
Yeah, thank you. So this is the velocity function, right? What about that acceleration function? It was simply minus 0.5 I hat plus 0.15 t j hat, right? Am I right?
Yes, sir.
Yes, sir.
Yes.
So now look at this here function. They ask you whether this car or that vehicle.
Sir,
Mhm.
minus 0.5 t
For what, velocity or acceleration?
acceleration.
I don't think so. It for acceleration it should be t independent or x position.
Oh, okay.
Acceleration was actually that independent. X component is independent of the time, but the y component is dependent. That's why it's a 0.15 t. All right.
Yes, sir.
Fine. Now tell me, is these two function is constant with respect to the time? Will it be constant?
No, sir.
Because if you plug in the t equal to different time, let's say t equal to 0 second, then the value should be what?
The velocity will be 0.
The velocity will be, sir, 1.
1 j head, right?
One.
1 J.
1 j
One,
head,
sir.
right? If
One,
you
sir.
yeah, exactly. So it's not 0. So if you that's mean if you plug in different time, so different time velocity will be different. And also the acceleration. Look at this acceleration. Y component is depend on the t, which means it is not also the constant, right? It will be changed at different time. T equal to 0 second, the acceleration of the car will be 0.5 I head, minus 0.5 I head. But at t equal to 1 second, it should be 0.15 I head plus 0.15 j head, which means it's changing both the velocity and acceleration. So that's why I can say that this car is neither moving at a constant velocity nor constant acceleration, right? Since these two function, velocity and the acceleration, will be changed with respect to time, that's why it will be not moving at a constant velocity or constant acceleration. That's why it should be the answer. Is it clear to everyone?
Yes, sir.
Even though if you are very smart, if you just look at these two equation, this is actually that position function over here. It's a t square, and also there is a t cube over here, which means that after taking that first time derivative, both two function will be as a dependent of t, which means first time derivative means it's a velocity function, which means that velocity will be depend on the t. Depend on the t means it will be changed at different time, which means the velocity is not constant, which indicate that the car will be not moving at a constant velocity. Same thing, if you take that second time derivative, in that case this acceleration, a x component will be independent because it's a t square over here, but the y component is a t cube. After taking the second time derivative, its y component would be also as a function of t. So that's why the acceleration would be also as a function of t, which means that the acceleration will be changed with respect to the time. That's why I can say that the system will not move at a constant velocity nor at a constant acceleration. If you just look at this equation without doing that calculation, you can say over here. Right, you can make that assumption or make on a comment on that. So that should be the answer. So this car or the vehicle, robotic vehicle, will be not moves at a constant velocity nor at a constant acceleration. All right, now let's move for the next question. They asked me try to draw that velocity Vx versus t, Vy versus t, and also Ax versus t and Ay versus t, right? Can anyone tell me what should be that curve
Yes.
of this Vx versus t? This is my t, this is my Vx. What should be this curve look like? Can anyone tell me? What should be this Vx versus t? Velocity function is this one, right?
Yes, sir.
So then what should be that curve? Can anyone tell me, or at least make a guess?
The parabola.
Parabola. Only Vx, not the Vy. Vx, only the Vx component.
So it will be a straight line.
Straight line, then
It will go through the origin. I guess.
passing through the origin. Yeah, obviously. Look at this. Your velocity function is this one, right? So if I write, it's a 0.5. I'm taking only the magnitude, not the vector right now. So let's drop that vector sign. my velocity x component is simply 0.5 t, right? This is the Vx. It should be simply y equal to mx curve. Can I tell that one?
Yes, sir.
Then it should
Yes,
be
sir.
obviously
Yes, sir.
passing through the origin. Alright? If you don't believe me, I can show you that. There you can find out a lot of tools actually online that are available. This is called Desmos. Are you familiar with this one?
Yes, sir.
No,
It's an
sir.
online tool actually. If you write, you can, let's say we have this 0.5 into x. Look at that curve. Alright, so that's it, because his slope would be basically the same to the 0.5. So that's why it's a y equal to mx curve. Obviously, it is going to be passing through the origin. That's why Vx versus t would be look like that curve. Alright, now what about the Vy? Vy function is 1 plus 0.75 t square. So Vy is 1 plus 0.05 t square. What should be this curve look like? This is my t and this is my Vy. What should be look like this curve?
So it will be parallel. Sorry, parabola.
It should be parabola, yeah. It should be parabola, but condition is it will be, this is the yeah, right. So it will be not passing through the origin. It will be look like it will
Yes,
be
sir.
start from this point. Actually, is going to be the 1. This is going to be actually the 1. Still, who is giving me the knock? We can also check that one from this. If I write down, look at this. If you write over here, so 1 plus 1 plus 0.075 x square. Look at this. Right? It's a
Yes, sir.
It's a parabola. Got it. All right. So now the this is for ax versus t. What is the a function? Ax was minus 0.5, right?
Yes, sir.
And ay actually 0.15 t. Now tell me, what should be that ax versus t curve?
A parallel of x-axis.
Parallel of x-axis. It's a parallel of x-axis. It's a positive side from the negative side.
Sir, negative side.
Negative side, so obviously it's a minus sign, right? So that's why it should be
Yes,
over
sir.
here. And what about the ay versus t?
Sir, y equals to mx.
Y equal to mx. Obviously, it is also going to passing through that origin. All right.
Yes, sir.
That's how actually any
Yes,
equation
sir.
you can graphically represent those motion. And obviously, I'll give you some question on to that your quiz, mid or final, even though assignment you have to understand or you have to draw that one. Yes, is there any question over here? Someone probably raised your hand. You can tell me. Yes, Lamia, what is your question? Lamia, you raise your hand. Please speak up. Can you hear me, Lamia?
No, sir, I have no problem. It's mistakenly.
All right. Well, that's fine. Fine. So this is actually the question we tried to solve in your last class. Actually, let's move to the forward. Actually, so today I'm going to talk about, this is most important part actually I'm going to talk about over here today, which is actually motion in the 2D. You say that projectile motion, all right? You say projectile motion. I think I have that slide also. Where is that? Yeah, that's it. This is actually the projectile motion, you say, which is actually the two-dimensional motion, but under the influence of the gravity, right? So once you actually throw any particle or projected any particle with a initial velocity v naught making an angle, then the trajectory would be look like this one. This is called the trajectory, right? You know that one, or the path. Sometimes we say that the motion of the path of the particle. That's we say that trajectory of the projectile motion. Once you throw that particle into the air, if you neglect the air friction, we can say that force on that particle only should be towards the downward direction. That's why the acceleration will be also the downward direction. And that's why I'm saying that this acceleration will be always minus 9.8 meter per second square. Minus means it should be towards the downward direction. And there will be no acceleration along to the horizontal direction, right? Do you understand this one? This is the most important parameter of this motion or important characteristics, and that's why it makes it special. Same particle have the two different characteristics. In one direction, it moves at a constant acceleration, which is minus 0.98 meter per second square. On the other hand, in the x direction, it moves at a constant velocity. So that's why its acceleration is 0 along to the x direction. Same particle at the same time have a two different distinction motion. One is moves at a constant acceleration, and the other side it moves at a constant velocity. That's why it makes a special case actually, the projectile motion. All right, remember these two key points actually. In one direction it will move at a constant velocity, whereas in the other direction it will move at a constant acceleration. That's why we will use the general displacement equation for this motion along to the x direction. If you write x equal to x naught v naught xt plus half of axt square. This is the general displacement equation I derived in your class in the last week. Since this moves at a constant x velocity, that's why this acceleration would be the 0. We write down that one, right? If acceleration is 0, then this equation become x equal to x naught v naught xt. If we start from the origin, then this is also going to be the 0. Then you can write down, simplify, this equation should be v naught x into t. This is the equation we will use throughout that actually this motion. If it is the start from your origin, remember that part. And along to the y direction, it will move at a constant acceleration, which is minus 9.8 meter per second square. So that's why I'll use this equation y equal to y naught v naught yt plus half of ayt square. Remember, in this equation, these are all parameter will be along to the y direction. This is the v naught y means it is the initial velocity along to the y direction, and v naught x means this is the velocity, initial velocity of the particle along to the x direction, which is simply that coefficient or the component of this vector actually. You know, you can find out this is my initial velocity, its component along to the, if I take different color, its component along to the this direction would be v naught x, and along to the this direction it should be v naught y, right? Now v naught x you can find out. How I'm going to find out? It's a component. This is my vector. It's create an angle theta with my x direction. Obviously in that case it would be v naught cos theta, right? And the other component which is v naught y, it should be v naught sin theta. That's why this is the initial velocity component. I also find out over here. This is actually that v naught x, which is the initial velocity along the x direction, and v naught y is the initial velocity along to the y direction. These are the initial, remember, which is in terms of v naught cos theta, v naught sin theta. All right, now let's picturize this motion actually in a bigger thought actually. I'm going to draw over here. Look at this. I try to draw that motion, and I also try to explain in terms of that component how it's changing with respect to its position. This is my x axis and this is my y axis I draw. I projected that particle with initial velocity v naught, and then I also take that initial component which is v naught x along to the x direction and v naught y along to the y direction, and these are actually that velocity when it's going to the upward direction, velocity the upward, and acceleration actually the downward direction. And this is the vy which is towards the downward direction, and acceleration is also the downward when it's going to the downward direction. Actually this is the two parameter. Look at this. Once you throw that particle into the air, I know that it has acceleration only along to the y direction, which is minus 9.8, and it has no acceleration along to the x direction. It means that along the x direction it moves at a constant velocity. That's why look at this. I try to draw this vector is same. It's not changing its length actually along to that x direction. I try to draw exactly equal because it moves at a constant velocity along to the x direction. So that's why this vector would be same throughout its journey or throughout its motion. Am I right? Well, on the other hand, when it's moving to the upward direction, this Vy will be gradually decreased. Why? Because it's moving against that your force or acceleration. Because force is downward, you're moving to the opposite direction. So that's why in the vertical direction, it has to be deaccelerated. Upward direction, if you move to the upward direction, your force is downward, which means the acceleration is the downward. Velocity vector and acceleration vector are in the anti-parallel vector. Obviously, system will be slowed down. Remember, I said in that beginning of this motion chapter, if these two vectors are in the same direction, the system will be accelerated. If these two vectors are in the opposite direction, the system will be deaccelerated. That's why when this particle is moving to the upward direction, this Vy is going to decrease, and at the top point it becomes 0. Vy component, not the total velocity, remember, because the total velocity at any point you can write down it should be Vx I plus Vy j. These are the two components. Summation of these two components will be the total velocity on this trajectory. That's why when it's moving to the upward direction, its velocity y component will be gradually decreased, and at the top point it will be 0, and the top point you can say that resultant velocity will be simply Vy z hat. Alright, so just after crossing that top point, now the Vy will be downward, and right now since these two vectors are parallel direction, which means the angle is 0 between these two vectors, then the system will be accelerated. That's why this velocity is going to be the increase. And I try to draw that vector length, gradually I try to increase that length. And it will be exactly hit at the ground with the same velocity if we neglect the air friction and if the vertical displacement is 0. Remember, I throw from that height, it's traveled this journey, and if it is strike over here, which means it has the same vertical displacement. Vertical displacement actually 0 over here. So that means they are in the same height. Come back to your original height, vertical height. Then the velocity will be the same. Whatever the velocity you thrown, it will be exactly strike with the same velocity if you neglect the air friction. All right. Now, what will happen if you goes to that beyond that point? Beyond that point means you throw that point, but you are still going to the downward direction. Your Vx will be still same because there will be no acceleration along to the horizontal direction. It moves at a constant velocity, whereas this Vy will be increased because right now it's still going towards the direction of your force. So that's why this velocity is going to be gradually increase over here. In that case, I can say obviously whatever the velocity over here, it will be higher than that one because Vy is greater than from that part. That's why you can also make some assumption over here. If you just look at this equation or velocity component, you can say that whether this particle is going to the upward direction or the downward direction. Let's say the velocity at any point at any time of this particle is 2I hat plus 3z j hat. Both components are positive, then I will say it is still going towards the upward direction. it is still not crossed that is maximum height. If it is crossed the maximum height, then this Vy must be equal to the negative. Then it should be look like 2 I hat minus 3 j hat. Then I can say that it crossed the maximum height. That's why the y component is negative. It means it's coming to the downward direction. So if you find out Vy or total velocity is simply 3 j hat, then you can say that the particle actually on the highest point on its trajectory. Highest point means this point actually where the x it has it has I hat, not the j hat. It has only the x component. It has no y component over there. The y component must be become 0, right? That's actually you can understand this motion in physically actually if you just look at this equation. All right, from that part we make some assumption actually. Look at this, I write at top point Vy, the vertical component, remember Vy means the vertical component will be the 0, but the Vx not equal to the 0. Total velocity would be simply Vx because your y component is 0 at the top point. All right, so if we consider that ideal situation up to that point actually it hit the ground, whatever the time it will take to reach from bottom to the top point, it will also take actually a same time from top to the bottom point if we neglect the air friction. So that means whatever the time it will take to go to the top point, which is we say that the T up, it will take exactly the same time from top to the down point. We say that that time actually the T down, and that's why in the second characteristic I write T up must be equal to the T down. Remember, if the vertical displacement is 0. Vertical displacement 0 means, let's say I throw that particle from here and it's again come back over here. Its vertical displacement is 0. It goes from there but come again in the vertical same level. Then it has vertical displacement is 0. But if you throw something top of a building and it strike the ground, then it has some vertical displacement which is this one. Then you cannot say that the time to take from this point to that top and top to bottom will be same. It cannot be same. It has the different time of flight. It will be only possible if the vertical displacement is 0. Remember this, these are the very crucial point for this motion I am talking with you, and we have to use this randomly actually those part. And I said the total time of flight actually, which is actually that flight of time, we say that in that time your particle or ball or anything you throw in would be in the flying mood. That's why it's called the time of flight. So, and for this case is time of flight or the total time would be basically T up plus T down, which is actually the time you are considering from coming to from that point. You start from there and it goes and come back over here. That's actually the total flight of time. But it could be sometime different. Right now I give you over here. This is also total flight of time, because if I throw something over here and it strike the ground, at that time it is also in the flying mode. It is also the time of flight. Remember, the particle which is actually into the flying mode, that's called actually the time of flight. And for this case, total flight of time will be T up plus T down. You can write it in that way. And we can say since T up equal to T down, we can say that T total flight of time would be simply 2T up. We can also make this assumption from here. And one more important thing actually we need to understand, which is actually we say that range would be only if the vertical displacement is 0. We have that range idea, right? We say that if you throw a particle, let's say I throw a particle from this ground, it is strike the ground again, and we say that displacement actually the range. What if that case I say you, let's say you throw a ball from the top of the tower or top of your building and it strike the ground, will that displacement be range? It's a no, it's a big no. Or vice versa, if you throw something from a ground and it strike the top of a building, that you cannot also say that it will be the range, because there are some vertical displacement over here. But this case it has no vertical displacement. That's why you say that it is range. for the range, the vertical displacement should be the 0. Or I use another way, this I say only that horizontal displacement, all three are horizontal displacement, horizontal displacement, all three you can say that horizontal displacement, but the range should be only when your vertical displacement is 0. These two are not the range because it has the vertical displacement, but this one actually the range, you can say that. That's why I write down the range equal to only vertical displacement is 0, otherwise not. One more important parameter, we say that theta and 90 degree theta has the same distance, which means let's say I throw a particle making an angle 30 degree, its trajectory would be look like this one. If you throw a particle with a angle with the same velocity, actually making an angle 60 degree, then its horizontal displacement would be same, but the time period would be different over here actually. It's a time up and the time down is not exactly the same, right? So because it's traveling the larger vertical displacement with respect to that one, but that horizontal displacement would be same. So that's why you say that theta and 90 degree minus theta will be covered the same horizontal displacement. This is very important characteristic of this motion. All right, now come to that part. Some other equation actually you memorize from this type of motion actually, which is we define actually T up, T down, maximum height, range formula. Do not try to memorize this one. It could be find out from there. I'm going to show you over here. Let's say I'm going to find out that one. You throw a particle with some initial velocity v0, making an angle theta, and it makes a trajectory over here. I'm going to find out how much time it will take to reach at that top point, and also the down point. It should be the same because it's the ideal situation right now over here. So T up, that's we say actually the T up or the T down actually is the same time, right? Fine. So, and if memorize probably that formula, obviously some of you memorize, but my prescription is please do not try to memorize. You can find out using that idea. I know when this object will be reach at the maximum point, what should be its vertical component velocity. At the top point, I know the Vy actually the 0, right? And I can find out Vy velocity, which should be V0 sine theta minus gt. Can I write down this one? I write down that formula actually. V equal to u plus at. But since I am dealing with that vertical component, so that's why I write down the Vy actually V0 y plus ayt. V0 y I can find out because this is the component of that velocity along to the x direction and y direction. V0 x should be simply V0 cos theta, and V0 y should be V0 sin theta. Are you getting my point, guys? Am I with you?
Yes, sir.
Yes,
All right,
sir.
that's great, because sometimes it happens actually. I'm talking, I'm lecturing, but the people I am already disconnected from the network. I do not know. That's happened. I have that experience actually on the online semester. All right, so this is should be that from that one I write down this equation. This is should be that velocity in the y direction at any moment. Now I know that velocity y component should be the 0. Then I'll plug in over here. It should be v0 sine theta minus gt. Please silent yourself. Mute your. So then I'll find out this t is going to be simply v0 sine theta divided by g. That you say actually is the t up time. You memorize this equation, right? But my prescription is do not memorize this equation. Instead of memorize, just plug in your value into this equation. It will give you exactly the same value. Did you get my point? Without memorizing this formula, you can find out that T up, how much time it will be take to reach at the maximum point, using simply this equation V equal to V0 y plus ayt. Now if you ask me why does this equation come? This equation come from here. You say y equal to y naught v naught yt plus half of a yt square. If you take that first time derivative of this equation, you will find out this one. If you don't believe me, you can check that one. Alright, so that's mean using that formula, we can also find our time of flight at different level. Or you can use directly this formula also. There is also some point, I will show you sometime. Alright, so this is to be actually the T up equal to the T down. That's going to be the simply V naught sine theta divided by G. Now, if you want to find out total flight of time or total flight of time, that's going to be the simply T total. I write down, so it should be T up plus T down, right? For idle situation, T up plus T down obviously is going to be actually is a 2 of that 2 V naught sine theta divided by G. That's actually we define the flight of time. You memorize. I'm not going to say you should memorize, but what will happen? This is the case actually. This equation you can write down only if your vertical displacement is 0. What will happen? Let's say I throw it from here at the top of a building and it strike the ground. I want to find out this time. How I'm going to find out that one? In that case, this equation is not going to work for you, remember. But you can use that formula y equal to y naught v naught yt plus half of a yt square. Both situations, this situation and this situation, you can use this formula to directly find out total flight of time. How? If you think about for this case, what is the idle situation? This is actually total time of flight. Let's say I choose my origin from there, then what should be my y naught?
So there will be some particular value.
Y naught, if we start from the origin, let's say this is, I throw the particle from my origin, then what should be the y naught? This is my y.
0, sir. 0, sir.
It should be 0, right? Obviously, this is going to be the 0. And if it is come back in the same height, then what should be this y? Which is the vertical displacement.
Sir, at which point?
I throw a point here and it's again come back, strike the ground. Then what should be the vertical displacement of the particle?
0.
It should be
0,
obviously
sir.
0. Good. Both are 0. I find out this v naught y from this part because you throw that particle v naught, you can find out the v naught y, and you know this one, then you can find out the t from there. So that's the time of flight. And that you can also do for this case also. Let's say when you throw something from top of a building with some initial velocity making an angle theta, you can use the same case. In that case, your vertical displacement is not going to be 0. You will find out some y over here. Into this equation, using that one, you can find out the time period in any situation. All right. So that's why I'm going to request you try to cope up with this general displacement equation. This will help you a lot. This will help you a lot. I'll show you. So that's why this will be actually that time of flight equation. All right. So we find out the time of flight actually, or T up. Now let's find out your, I'm trying to show actually the equation actually memorize. Let's say I want to find out what should be its maximum vertical displacement, which is actually, you said that probably the h, right? You memorize that one again, and most of the time actually people make a mistake to write down that formula from his or her memory. But I can do in another way actually using this equation, because I know I want to find out the vertical displacement when it reach its maximum height in the vertical displacement, right? It can be done in the two way. Look at this. I know initial component Vy actually it should be V naught sine theta, right? This is the initial component. And now I am looking to find out, I also know the time actually, the T up, which is actually that V naught sine theta divided by G. I already find out that one. Fine. Now I am going to plug in this value into this equation. If I plug in, I am looking for y. Let's define this is my origin. Then the y naught is 0. I'm just plugging those parameters into this equation. Plus v naught y actually v naught sine theta, and t is, which is the t up. This is the t right now I'm looking for when it's reached at the maximum point, which call actually the t up. Then the t up actually v naught sine theta divided by g minus half of g. I use the g instead of 9.8 because we also use the z over here, into that t up square. T up square will be v naught square sine square theta divided by g square, right? So then look at this, you can neglect one g from there, you will find out this y is going to be the simply v naught square sine square theta divided by g minus half of v naught square sine square theta divided by g, right? Then I'll find out this y should be over here. You can factor out this one, v naught square sine square theta divided by g. You can factor out, it would be 1 minus half, which means it would be simply v naught square sine square theta divided by twice g. That's the formula you say that H max, right? Did you memorize this formula?
Yes, sir.
This is called actually that
Yes, sir.
maximum height from the, but I don't have to memorize this one. If I just plug in my value into this equation, I'll be able to find out that maximum height. If I just know the time, how much time it will take to reach at maximum point, then I'll be able to find out that what should be the maximum height. Not only that, I can find out at any position on this trajectory what should be its height. If I just know that time over there, I'll be able to find out at any point on this trajectory. If I just know how much time it will take to reach into that point, I can obviously find out what should be that height of that point using this equation. That's why this is most dynamic equation. If you, let's say, if you do not know the time, then how are you going to find out? Someone can ask me, let's say you are going to find out at any point, you do not know the time, then how are you going to find out that one? That could be also done. Now the question is how, right? Let's say, let's find out at maximum height point. I do not know the time. When it goes to the maximum height, I also know that velocity is the y component is 0, right? Am I know that one? I know that
Yes,
one,
sir.
right? Then I'll write in this equation Vy, it should be V naught y square plus 2ay or g into y, which is I'm using v square equal to u square plus 2ax, which is for x direction. Right now I'm writing for the y direction. Vy actually the final velocity, that is 0. V naught y actually the initial velocity in the y direction, which is actually this component, which is the v naught y. I know if I throw that one with that initial velocity v naught making an theta, then this v naught y should be v naught sine theta square, right, minus 2 into ay would be g minus g actually into the y, right? Then I can find out this part, this y is going to be simply v naught square sine square theta divided by twice g, which is exactly the same equation for that maximum height equation, right? So that's mean without that memorizing those equation, you can find out. If you just know that at any point your velocity, you will be able to find out that height using that formula. All right, that's the procedure to find out this parameter actually. So I'm trying to show actually, you don't have to derive this part actually. I'm trying to show you that without memorizing those equations, if you just use only one equation, you can find out those unknown parameter from this equation. All right, let's move forward. What about that range actually? I'm not going to say that range. I will say that horizontal displacement. This one, I will say that horizontal displacement. If the vertical displacement is displacement. If the vertical displacement is 0, then you can say that range, otherwise not. To find out that range, let's think about the ideal situation. You throw that particle with some initial velocity v naught, making an angle the theta, then I want to find out what is that distance, which is the x over here. Alright, remember, along to the x direction, I know that it moves at a constant velocity, so that's why I'll write down this x should be x naught v naught xt plus half of axt square. I'm writing from beginning so that you can understand. So since it moves at a constant velocity along to the x direction, so that's why the acceleration will be 0. I should choose, this is my origin, then x not will be 0. Then I'll find out simply this formula, x equal to v naught x, which is actually that constant velocity formula, s equal to vt format, right? Fine. Now what is the v naught x? V naught x would be simply v naught cos theta. And now what is t? T is the total flight of time, when you time going to find out from traveling from that to that distance. That should be actually 2t up, 2 into v naught sine theta divided by g, right? So that's mean, which is, you can plug in over here, it should be v naught x should be v naught cos theta into 2 v naught sine theta divided by g. Alright, then I'll find out this x is going to be that v naught square to sine theta cos theta divided by g. Alright, then I'll find out x should be v naught square, 2 sine theta cos theta, actually write down sine of 2 theta divided by g. Alright, then I'll find out this x should be simply v naught sine 2 theta divided by g. That's we call actually that range formula, v naught square. And if theta is 45, then we say that we say x max, which should be v squared divided by g. That's called actually the maximum horizontal displacement or maximum range. But my point is, I try to show you those are the equation actually memorized, but instead of memorizing, you can use simply this equation along to the x direction and along to the y direction. Then we will find out, explain those parameter at any situation. Alright? Do you understand? Is there any question over here?
No, sir.
No, sir.
Alright, now come to the real game actually. Let's say not that bird. Remember, we try to find out that in the vector chapter you did your assignment, you have a 18-meter long tower. You find out that length of this string. Right now, let's do some experiment. From that tower, you are at the top right now, you throw a particle with some initial velocity 30 meter per second, and it's going to be strike the ground, and this is the 80-meter long. Now my question is, where it will be strike the ground and with what velocity? At what velocity it is going to be strike the ground? This is my question over here simply. Now if you write down, because if you want to find out that displacement, you need to the time, or I can ask you what should be its time it will take to come to the down, because I need that time also. If I do not know the time, I cannot find out. Alright, it could be done, but let's find out what would be its time of flight. This is also time of flight right now, because at that time it is in the time of flight mode, right? Now if you write down that formula, t up or the t down, v naught sine theta divided by g, what should be that t up or the t down? This is actually the t down. What should be the t down? Your v naught actually,
0, sir.
yeah, v naught is 30, but the angle is 0, right? So sine 0 is 0, So 0 divided by z is going to be the 0. Does it make, is it meaningful? If you throw something with 30 meter per second from 80 meter, your equation is telling you it will take the 0 second. That's when it will be instantaneously fall into the ground. But which is wrong, which is not right. That's mean this is not the general formula. This is the very special formula you memorize for projectile motion. That's why I'm telling you, please delete those equations from your memory, from your hard disks. Those are the garbage equation, I say. I'm sorry to say, but that's true. It's simply the garbage. Because I said the garbage because those are the thing is not going the helpful for me in the real life case. Then why I will memorize those stuff in my brain cell? Fine, then how we are going to solve that one? Obviously, I have that equation y equal to y naught v naught yt plus half of a yt square, right? Let's choose, this is my origin over here. It can be choose the origin also over there. It's interesting, try to understand. If I choose the origin at the top point, what should be the my y naught?
It will be 0, sir.
It will be 0.
For
Yes.
What should be the v naught y?
So it also will be 0.
Yeah, those who are not getting why the v naught y is 0. What is the v naught y in this equation? V naught y actually that initial velocity along to the y direction, but you throw that ball towards the horizontal direction initially, right? So that's why this v naught y is also the 0. And this you can write down, it should be minus 9.8 divided by 2 is going to be that 4.9 t square. Now what should be the y?
the minus 80 meter.
It should be minus 80 meter obviously, because you are going to the downward direction of your origin. If you have that Cartesian coordinate system, if you goes from origin to the downward direction, that parameter would be negative. So that's why y would be minus 80 over here. Now you can solve this equation, right? If you solve and you can find out, it would be simply t would be, I can drop this minus sign from both sides, then it should be 80 divided by 4.9 square root, right? And someone, let me, what is my calculator?
Sir, 4.04 second.
4.04 second probably, yeah. 4.04 second, that's the time it will take to reach the ground. Now if you want to find out why it will be strike, I'll use x equal to x naught v naught xt. I'm doing again for you a naught xt. How does this equation become? Along the x direction, I know it will move at a constant velocity, x will be 0, and this x naught I can also consider 0. Then I'll find out simply x would be v naught x into t. I find out that t, which is the time of flight. Now what about that v naught x? What is the v naught x over here?
It's 30, sir.
It's a 30 initial velocity along the horizontal direction. You totally throw that particle initially towards the horizontal direction. So that's why it should be 30 into t 4.04. It should be probably 121 point something meter. So that's would be the displacement of the particle if you throw with 30 meter per second from 80 meter tower towards the horizontal. Then it will be strike the ground at 121 meter from your foot of your tower. Now with what velocity it will be strike? This is the question. It's a velocity. Just remember you have to make in the direction over here. What should be that velocity? Now tell me, when it's going to strike the ground, how many component would be over here? One component or the two component? If it strike the ground over here,
Sir, one component.
one component, which direction that is?
So towards ground.
Towards ground. No, tell me in terms of my this Cartesian coordinate system axis, x and y axis. It has the two component. It is the two-dimensional motion. One would be x component, Vx, another would be that y component. Right? Does it make sense to you?
Yes, sir.
It has two components because it's a two-dimensional motion. You find out the resultant of these two vector that you say, that is that we can see resultant vector at that velocity is going to be straight. But it has two components obviously, Vx and the Vy. Now the Vx would be what over here? You know from that it moves at a constant velocity throughout its journey. This Vx is going to remain same, right? Am I right?
Yes, sir.
Which means this Vx would be 30 meter per second, right? Now the Vy over at top point is 0. Gradually right now it will be increased, right? Because it's moving towards the direction of this acceleration vector. They are parallel vector right now. So that's why the Vy gradually will be increased. I can find out that Vy. So I can write this total velocity will be Vx I hat plus Vy z hat. Vx would be simply 30 meter per second. Now the Vy I need to find out. I am looking to find out that velocity after throwing 4.04 second. Then I am supposed to write Vy should be V naught y plus ayt. I am using V equal to u plus at formula, but in the y direction. So that's why I write down in term of y coefficient. Now what is the V naught y? Let's write down over here. What is the V naught y? Oh God. What is the V naught y?
0, sir.
This is 0, obviously, yeah. This is 0 minus 9.8 into t is 4.04. Now tell me what is the y? Let's say probably 38 point something, probably 9.8 into 4.04. Yeah, 39.
So 39.5.
Yes, it should be minus 39.59. Then I can say that my resultant velocity V should be 30 I hat minus 39.59 j hat. That's the velocity. At that velocity is going to be strike the ground. Now if they ask you to find out the magnitude and the direction, I hope you can find out by yourself. That stuff we already learned in our previous chapter, right? This is the process actually we can solve the projectile motion in the 2D. I'll do 2 or 3 more problem actually in the next class, and I also do some real life problem actually. I'm going to show you. Those are the problem actually I solve. This is one case actually. You throw the ball towards your wall with some, I'll ask that parameter. This is a football match actually I'm going to talk about between the two player, and this is the tennis player. They serve the ball. We will also handle this part using this idea, and this is actually the basketball game actually we'll discuss into our next class. All right, that's all for today. I'm done with you. Thank you very much. Do one thing actually.
Sir,
Yep.
sir, you have told us that you will share the cover page with us of the assembly.
Oh God, I forgot about. Thank you very much. Thank you very
Sir,
much.
sir, can you please tell us something about the next quiz also?
Next quiz, the topics actually I'm going to talk about. This will be the topics of your next quiz topics.
Sir, did you mention about the date of our next quiz?
Not exactly the fix, but I give you that idea. It should be in the next week actually.
Okay, sir. Yes.
Okay, sir.
All right. Do one thing actually. Give your attendance. Just write down your name and ID into the your chat box. Everyone do that. Everyone do that. Hurry up actually within 2 minutes.
I just want to stay in the sun.